Hi, I'm Rich Breckner from Inside HPC, and today my guest is Joe Landman. We're here at SC10. Joe is CEO of Scalable Informatics. Welcome, Joe.
Thank you very much, Rich.
Joe, I think the best place to start is, can you tell us a little bit more about the company? Who is Scalable Informatics?
Certainly. Scalable Informatics is a high-performance computing solutions provider. We design and build the most scalable, most high-performing systems that we can for our customers to solve their real-world problems. We focus on providing pragmatic solutions to our customers' needs instead of simply trying to find the highest theoretical bandwidth and theoretical performance. We actually try to achieve real, actual performance for our customers. We formed the company in 2002, on actually 8/1/2002.
Okay.
So we've been in business for roughly 8 years and a couple of months, and growing and profitable.
Okay.
We're in pretty good shape.
All right. You just may be the first CEO blogger that I know of, and you're probably not the one who gets the most credit for that, but that's another story. Okay. Let's shift gears. I understand you have a new storage product?
So what we have is a new scale-out NAS type product, and this product is named siCluster NAS, the Si, of course, being Scalable Informatics. And the whole concept behind this is to make very easy, very high performance, and a very cost-effective scale-out NAS capability, providing both NFS and CIFS, as well as, for people who are interested, GlusterFS type client access. What we want to enable in this product is the lowest cost we can possibly get on a per terabyte basis. So we're looking at $1,000 per terabyte typical list price for most configurations, and we can scale up these systems through multiple petabytes relatively easily and at a very low overall cost. The bandwidth going into these systems for our NFS and CIFS customers increases very linearly with the number of nodes that we add into it, and the overall I/O performance on a per node basis. We're using a lower end product of ours, our Delta V, which this is based on. We're using that as the base storage node, but each I/O node in the system adds 800 megabytes a second sustained read and write performance. So we're able to, with 2-node, 3-node, 4-node systems, achieve 2 and 2.5 gigabytes a second sustained for NFS customers as well as CIFS customers.
So you're adding bandwidth as you add storage?
You add bandwidth as you add storage.
Okay.
And what we're trying to do there is we're trying to prevent the formation of what we call a storage bandwidth wall. In other words, the more storage you hide behind a fixed size bandwidth, that takes much longer to ever read or write that entire amount of storage because you're limited in what you can access. And so if you have a fixed size pipe, say a 1 or 2 or even 4 connections into a filer head, and you have all your storage behind that filer head, then as you increase the size of that storage, you will never be able to read and write all of that data. That storage will be cold, it'll be effectively frozen, it'll be useless to most end users. What we want to do is we want to allow them to use this data. We want to allow them to access the data, to process the data, and to do this at the highest possible speed.
That sounds great. Now, do you have a demo you can show us?
Yes, I can. We have let me describe the demo before we go over to it. We're actually running a financial services computation based upon a tool called KDB Plus from a company called KX, a partner of ours. KDB Plus is what's called a column structured database. And what we're doing in this particular demo is we're executing a query against this very large data set. It's approximately 31 gigabytes of data that we're executing the query against. And the KDB Plus and Q system will pull that data in from the disk systems and then process it and spit out an answer. And what's interesting is that we have a siCluster NAS unit connected over a single 10 gig connection to the node in question, and we're going to execute the query and also show some very simple streaming bandwidth data for the system. I should also point out that this is a slightly older model version of our target storage device, so it'll be a little slower than the other systems.
Sure.
So.
Okay, let's take a look.
So what we'll do is I'll show you what the system actually is doing for this query. We're basically running a very simple script, and the simple script, the very first thing that we do in our simple script is we drop our caches. We want to operate on what we believe to be cold data. We don't know if our customers will ever operate on hot data or on cold data, so we assume the worst case. And then the next aspect of this is we actually run the application against the data set with, as it turns out, 8 threads and the specific query. If we look at the query itself, this is digging into some details which we probably don't really need to get all the way deep into. This looks like a SQL type operation, but it's really not. So when we run it, the very first thing that we're going to do is we're going to drop the cache, as I said, and then we'll proceed from there. Now, one of the things that will occur is you'll notice in the window over on the right-hand side, you'll see some activity on the network side, and in the window beneath it, which is where the storage actually is. This is the computing unit. That's the NAS device. You'll see some activity on the actual disk operations. So when we run the query, it starts out. I did a cat on the thing. So as you can see, at the end of the day, I'm not particularly cogent. But there we go. Let's try it again. So when we run the query itself, you'll see we start pulling data out over the network and send it back, and we answer very quickly. And you'll notice that we're pulling. It was spread it out over a larger time window, but we're pulling about 1 gigabyte of data very, very quickly, which is a summary operation on these data sets. We also have a second query, which is very similar, again, where we, in fact, perform a very similar type of query against the data. And again, we drop the cache. We drop the caches as well as the very first operation, so we'll run that. And this is a much simpler query, but you'll see it operates extremely rapidly over the NAS device. The baseline unit itself, as I said, this is an older unit on the rear end of the unit. An older storage node on the backside of the storage cluster. And as just an example, we're streaming a 128 gigabyte write out to this unit, and we're doing it at approximately 1.5 gigabytes a second in a sustained manner. Now, this is very far outside of the system cache, very far outside of any sort of RAID cache, so this is actual raw data streaming to disk. This particular operation typically takes on the order of 86 seconds to complete on the storage cluster, and if we flip this over and do a read, what we see is a roughly 1.7 gigabytes a second sustained as returning from the storage cluster. And so that basically is the full demo. And I should also point out, while we're running this, if anyone is interested, we can in fact run the original query. And when we run the original query, it's still actually relatively fast, which means that these units can be used in a very multi-function use case. You can bang on them extremely hard, and they'll be happy to pull the data back that you need and push the data out to disk.
So Joe, we saw the demo. Can you summarize the product for us?
Certainly, I'd appreciate that. So what we're trying to do here is we're trying to make this as scalable, as performant as possible at a very low price point, at a very easy to scale up and very easy to manage scenario, and make end users accessing the system as absolutely easy as possible. We're leveraging best of breed technologies throughout so that we have the easiest connectivity. We're leveraging the GlusterFS file system, the 3.1 version, that allows us to use both NFS as well as their Gluster client. We're leveraging CIFS when our customers require it. And at the end of the day, it makes it very easy to grow this, to connect to this, to expand this, and we're trying to make sure our customers can access that power as easily as possible. That's really the take-home message, and as inexpensively as they can.
Okay, thanks for coming on today.
Thank you very much, Rich.
We'll see you later.
Take care.